Another term that we want to become used to and comfortable with is this idea of bearings. And bearing basically helps us identify one point's position relative to another point. And the prescription of how we do that is, imagine then that we have some center point or our initial point and reviewing a distant point. In this particular case, I have three examples. So this is point P. Well, how we do the bearing is that we develop a acute triangle and look at the angle measurement from the up and down vertical axis, from the north or the south. So for example, this is 40 degrees from the y-axis. So I would say the bearing of P is on a heading going north 40 degrees east. The blue one has a heading of north 65 degrees west. 65 degrees is not measured from the x-axis. Again, it's measured from the y-axis. We start with the north or the south direction first. So north, 65 degrees in the west direction. And then a red one down here. Notice the angle is 70 degrees. Again, measured from the y-axis. Initial point 0. The other point is R. So R is at a heading or a bearing of south 70 degrees east. So let's look at an example and see if we can interpret and find some of the information that's available, and some of it is missing, to determine the bearing of each of these 3 or 4 points. Notice again, a bearing is a point relative from one point to another. And so let's say I have some center point, and I'll mark that O. So what's the bearing from O to A? Well, it's in the northward direction. I have to measure the angle, though, from the y-axis. From the north axis. It's not labeled. However, I know it's 20 degrees over on the other side to the x-axis. So what do you think the remaining degrees must be? True. It's got to be 70 degrees. So 70 degrees, so it's north 70 degrees east. All right, what about the bearing from O to A, or from O to B? Well, it's in the north direction again. The measure angle has to be from the y-axis. In this case, it's already labeled 40 degrees, and it's in the west direction. O to C, it is in the southern direction. The measurement is 75 degrees, but that's not measured from the y-axis, it's from the x. So the remaining then has to be 15 degrees in the western direction. So south, 15 degrees west. And then O to D, what do you guys think? I think you're right. South, 25 degrees east. And so there's a little bit of using some trigonometry, some understanding of complementary angles, and then directions, north, south, east, west. Another example that we can kind of use trigonometry and bearings. So imagine that we have an island with some harbor, and we have a boat that left that harbor in a heading of north 42 degrees east and went for 25 miles. After 25 miles, the captain turned the boat clockwise 90 degrees and then continued on a heading at south 48 degrees east for 18 miles. So the current position of the boat relative to the harbor is what we're trying to discover. So we want to know how far away is he from the harbor, and then what is the bearing of in relationship to the harbor. What do we do? Well, first of all, we want to recognize is there a right triangle involved? And based on the description we were given, it is in a right triangle. So a right triangle then allows us to solve some right triangle trigonometry. First thing I want to find out is what's the distance from the harbor to the boat? Well, that's the hypotenuse of this triangle that I have here. So I have something that says 18 squared plus 25 squared equals the hypotenuse, or the distance this time, squared. Let's go ahead and do our black box here to figure out what that is. So that's going to equal the square root once it's all done. The square root of 18 squared. A lot of keys I got to find again. 18 squared. Whoops, wrong spot. Hold it. Let's just figure out this. Okay, 18 squared. So that's 324 plus 25 squared. I know you guys already know it. 625. So 625. Clear the square root of 324 plus 625 equals 30.8 roughly. So it's 30.8 miles. Now we need to figure out what its bearing is. And the bearing is related, it's this angle from the north down towards that. Well, we already know that 42 degrees of it's defined. We just need to figure out what this remaining part is, what that theta is. So is there a trigonometric function or identity I can use to help me determine theta in a right triangle? There is. That looks like it would be those legs, which are tangents. So it's the tangent of theta equals the opposite over the adjacent, which is 18 over 25. Since I'm trying to find the angle, I'm looking for the inverse of that tangent. And then to find out the angle itself is that theta equals the tangent of 18 over 25. And that one becomes tangent of 18 divided by 25. Sorry, inverse tangent. Yeah, tangent of theta inverse tangent of 18 divided by 25. Inverse tangent 18, punching all the keys this time, equals 35 degrees. .75, 35.8, 8 degrees. So that was my tangent right there, or my theta, or that's the degree of my theta. To find out the entire bearing, I need to add that to the 42 degrees. So 35.8 plus 42 equals 77.8 degrees. So my bearing then is from the north, 77.8 degrees, to the east is where my boat is at in relationship to my harbor. And yeah, let me just clarify one thing in here. I got a couple of inverse tangents in the wrong spot. I talked my way through it, but I forgot to kind of erase one. And so let me just remove that one right there. And so again, the tangent of theta is identified by its opposite over adjacent, which is 1825. However, if I want to find the angle, then I need to use the inverse tangent. So the tangent inverse of 18 over 25 produces my angle measurement.